Perfect. Thanks, Sinclair. Good morning, everyone. My name is Perry O'Hearn. I'll be moderating today's session. I currently work for Inter Pipeline, based here in Calgary, Alberta, and I've been in the asset integrity industry for just shy of 10 years. We got a great lineup of individuals from chemical vendors here today to express their views on the need to develop standard test methods and corrosion inhibitor evaluation and selection standards. Today's participants are Stephanie Power with Veolia, Jordan O'Grady with Baker. Forgive me if I get anybody's name wrong. Nihal Upscary with Clariant, Alan Jenkins with Schlumberger, Jeff Soderberg, and Les Smith with PureChem. I would ask before we get started with the questions and discussion that everybody that I've just listed out give a brief introduction, their name, and just their background. We'll start with Stephanie.
Thank you, Perry, and hello, everyone. My name is Stephanie Power, and I'm a business development manager focusing on the midstream industry in North America for Veolia, and I'm based out of Calgary. I bring over 15 years experience in the oil and gas industry to this discussion. My career actually began as a refinery operator prior to joining Veolia, where I've held several different roles over the last 12 years. I joined this JIP in August of 2025 upon transitioning to my new role, and it has been a tremendous learning opportunity for myself. More than that, I appreciate the greater good that this JIP is striving for, and I'm looking forward to our discussion today.
Jordan.
Hey, good morning, everybody. Jordan O'Grady with Baker Hughes. I currently lead our integrity management group in Canada. So that consists of all of our laboratory testing, product development, and application design and support for all of our customers in Western Canada. I'm a chemist by trade and now focused a little bit more on application, but obviously product development and performance testing is near and dear to my heart. So Kirk and I have been involved in this JIP for a couple of years now with Perry and Sankara and Io, among others, and really looking forward to the discussion today.
Nihal.
Yes, my name is Nihal Obeshekara, and I'm at Clariant here in the Woodlands in Texas. And I'm the head of global integrity management at Clariant. And prior to that, I was the corrosion manager at Multicam. And prior to that, I was a group lead and later section head at Champion Technologies. So I have been in this area for about more than 30 years now. And I'm looking forward to this meeting.
Perfect. Alan.
Hello, everybody. My name is Alan Jenkins. I was with SLB for 20 years, specializing in corrosion asset integrity, managing their global corrosion programs, but I left there in November of last year. Now I am an independent consultant based in Aberdeen. Thank you.
Thank you. Jeff.
So hello, my name is Jeff Soderberg. I'm the Director of Research, Product Development, and Laboratory Services for CES Energy Solutions, which is the parent company. That's why my PureChem. So CES Energy Solutions is the parent company of PureChem Services, JChem Catalyst, Canadian Energy Services, American Energy Services, among other different divisions across North America. So my education experience is in electrochemistry and corrosion, which I've been doing for the past approximately 23 years. I also have significant experience in chemicals for drilling, completion, simulation, production, and process. And yeah, I look forward to this discussion and see if we can move forward with some successful test methods. Thank you.
Thanks, Jeff. Les.
Good morning. I'm new to the panel, so sorry if I'm just catching up on everything. I've been in the oil field chemical business for the past 36 years. Started out with Treatolite, then Baker, and I'm now with JCAM, which is part of the CES group. Started out as an account manager, and then for the past 18 years, strictly midstream technology, to where I've designed treatment programs for customers strictly on the midstream side of things. Glad to be here, and hopefully I can have some input.
Perfect. Thanks, Les. Just before we get started, I would ask that the participants provide if the response they were looking to provide is in line with the previous discussion point. I would ask that they only provide the new addition and just say their response aligns with the previous discussion person who presented the discussion, just in an effort for timely progression of the discussion. So with that note, we'll proceed with the first question, and I will basically indicate the responder to each question. First question will be, why do you think the development of standard test methods?
Sorry, would you like to stop sharing your presentation if you
Oh,
don't mind? Sorry.
yes, no problem.
Thank you.
Why do you think the development of standard test methods is important? Open the floor first with Stephanie from Veolia.
So I think that standardized methods are crucial because they enhance consistency, comparability, and credibility across the entire industry. They provide a common objective baseline for evaluating performance, which benefits everyone involved. For suppliers, it helps to overcome the barrier to entry in an industry that is hesitant to take on new risks. And for operators, it lowers the perceived risk of transitioning away from steady state chemical programs by providing trusted, verifiable data. It also helps drive towards faster qualification, regulatory alignment by making the standardized tests make it easier to prove the environmental and safety compliance to regulators. And when we, as a supplier, have a clear universal benchmark, our research and development teams can focus on specific measurable improvements rather than guessing the operator criteria.
Sure. Thanks, Stephanie. Jordan, any commentary to that as well?
Well, I think that was an all-encompassing answer for sure. but yeah, obviously, so we've had the pleasure of chatting about this a lot over the generation of the GIP, and I think that, to me at least, the development of the standard test methods is important because I think at the end of the day, everybody wins from it. Like if we take the time, the effort to collectively and collaboratively develop these, there should be little pieces and tidbits that could be taken back to every person, whether it's the service provider, operator, third-party laboratory, that can essentially be used to further our industry from the generation of more confident data. And I think that's ultimately super important.
Thanks, Jordan. I actually see Kirk's jumped onto the call, so I'll actually allow him to introduce himself since him and Jordan do work together. Kirk, would you like to introduce yourself and maybe provide your commentary to that question?
I just hope my internet's stable enough because I'm in an office with really bad internet and I had to hotspot to get in. So I apologize for being late, but
No worries.
I'm just hanging on by a thread, I feel. But yeah, Kirk Miner with Baker Hughes. We had to consider for quite a while to join there, with the cost and budgets being tight. And I think for a long time as chemical companies with labs in different locations around the world, I think a lot of times we wanted to do things on our own. We felt there's maybe a competitive advantage. But when the industry doesn't recognize what you're doing or how you're doing things, and you go into RFPs or you try to develop products or applications and you're not sharing, the whole industry goes down a little bit because of that. So, caring is sharing, and it's really important for us to all be part of that greater greater knowledge base, and it does move the industry be forward. And it doesn't mean you stop innovating, you stop doing things, but at this point in time, this is the best practice, and that should be shared. So we've had to change some of our internal messaging and how we look at things, which wasn't easy, but I think we're better off for it.
Thanks, Kirk. Nihal, any comments?
Yes, I think Stephanie covered a lot of things in this area. And but on I have few comments. One is I work around the world with various customers. Some are very knowledgeable, some are not, and they usually ask us to run tests which are unbelievably bad. Tool is the same, but when the customer asks us to do something like that, we do it. Okay, but it does not serve the customer's purpose because we are not really doing correctly. So if when you have these methods written up and approved by everybody else, uh, I would say it is standardized the testing. To me, that's very important.
Thanks, Nihal. Alan, any additional commentary?
Yeah, just a couple of comments. So I think it's important to standardize the desk because at the moment when we get I don't know, an RFI for corrosion does, I mean, they can be open to interpretation. All the chemical vendors can do their own thing, slightly modifications on the test. So it's difficult for the oil and gas operators to compare apples with apples. So if, of course, if everybody's following a universal standard, a universal method, then it's easy for the oil and gas operators to compare vendor A with vendor B. So I think that's what's important. It will allow the operators to, more easily compare inhibitor A with inhibitor B, I think, but I think everything else has been covered. Thanks, Perry.
Yeah, thanks, Alan. Jeff, any additional commentary from you?
I think most things have been covered. Just maybe one or two quick things. I mean, one is basically streamlining testing. That there's an extensive amount of testing going on now, and I think with standard methods, we can kind of get to the answer faster. Everybody's doing the same thing. We don't need to do initial set of tests followed by kind of operator owner design tests. So I mean, that would be the one thing. I think it is kind of important to note that we need to get the right. I mean, all of this is hinging on getting the right method or the right standard methods, and kind of the benefit of this, what we're doing today and through this GIP is by working together, hopefully we can get that right method, kind of get that collaboration to agree on the right method or set of methods.
Thanks, Jeff. Great commentary. Definitely a lot of consensus among everybody here in the discussion. I'll proceed with the next question. What do you think are the issues if we don't develop standard test methods? We'll go in reverse order this time, just to make sure everybody gets a good chance to add their commentary. So we'll start with Jeff again.
So if we don't develop standard test methods, it's basically status quo. Everyone will keep doing things the way they've done in the past, which I mean, laboratories will run corrosion tests slightly or widely different ways based on what they think provides the best data for field recommendations. Another issue is data between labs cannot easily be compared, especially in terms of corrosion performance. And testing laboratory resources are used less efficiently, as testing will be done with lab-specific methods followed by owner-operator methods.
Thanks, Jeff. Alan, any commentary?
Yeah, I think these first two questions are quite well related. What we need standards. It covers the issues, but as I think, yeah, we need to get standards, as I said, because we need to be able to compare from vendors. We need to compare, third-party test houses to make sure that they are doing these methods correct. So I think the overriding issue of both those first two questions is simply so we can correlate results from all these laboratories. But I think that's getting more important now as well because a lot of the RFIs we have, or I used to have, these are very involved testing programs. They can take up to maybe 6 months, maybe 12 months. A lot of the tests are 28 days. That's a standard for an autoclave test for some operators. So that can introduce, quite variability in the testing, quite a large margin of error. So if you can standardize all these, we will be reducing these potentials error margins, especially in these long-term tests, which the results are very much open to interpretation, especially when it comes to assessing things like a localized or pitting corrosion, which is very open to operator interpretation. So I think that's the main issue. If we don't develop standards, the end users will be picking what they think is the best product, but it's probably not the best product because they haven't followed testing correctly. So thanks, Perry.
Well, thanks, Alan. Um, Nahil?
Yeah, I would also think a standard method, having a standard method for a system like RCE or RCA or whatever is important, because then the customers, uh, everyone who are using that or asking us to run these tests, can use that. However, it is also not something that is 100% accurate or 100% that we should be following it. It's because it depends on the situation. The situation changes. So standard doesn't mean something written in gold or stone. So it has to be there should be a variable that if the customer or somebody insists that you have to follow the standard exactly as it is written, I think it is up to discussion. And yeah.
Oh, sorry. Go ahead, Nahil.
Yeah. So that is my 2 cents.
Thank you for that. Jordan or Kirk?
I think you can definitely tell that there's individuals in this group and panel that have worked at similar organizations and have a lot of experience, whether it's been PureChem or SLB or Champion or Baker. And I think there's going to be a lot of similarities, and I agree with. And I think to summarize all that is trust. Really, I think like as an industry, there needs to be more collaboration. As an industry, we need to be able to trust each other and ultimately all agree that we're in the pursuit of the same thing. And I think if we don't at least start to develop this framework that then, like Sadine's comment and Nihal's comment, use that to further our accuracy when it comes to selection tests, for actually finding the right product at the right concentration for the right application, then I think that's the biggest issue. If we don't do that, the inaction will cause that lack of and degrading of trust.
Thanks, Jordan. Kirk, anything additional to add?
No, and really, it's we do see a lot go into third-party labs, and I think the standardization really helps when we go to third-party labs. We know we have a better idea of what their procedures are, and that drives more clarity on that. I think we've seen a lot where we've gone to third-party labs after doing our own evaluations, and the results are so very different. So standardization from that side, I think, becomes even more important, that we know how things are going to be tested. And then, we're always pushing for competency within our own teams, and this helps build our own competency matrices when we bring on new testers and things like that. So I think it's a little bit all encompassing.
I agree. Stephanie, any additional commentary?
Yeah, I agree with everyone's comments, especially Jordan's regarding building trust between the suppliers and the operators. But two more things that I wanted to bring up is the wasted negotiation time. So sales and technical teams often waste lots and lots of valuable time debating the testing methodology rather than discussing an actual solution, and as well as the slower adoption of greener technology. So, without a standard way to prove the efficacy of the new sustainable products against traditional ones, there's There's a slowness to adapt to these, even with the regulatory alignments. Operators want to stick with the products that they already know and trust.
Yes, I totally agree with you on that, Stephanie. You definitely get in a situation from the operator standpoint whereby, you know, uh, if alignment can't be reached within the chemical provider, from a commercial and technical standpoint, it really can hold up the overall process until everybody's really in alignment to go forward with an RFP. Um, with that, I'll move on to the next question. What do you think of the challenges and opportunities to developing a standard test method? We'll open the floor with this question to Stephanie first.
Sure. So for me, the primary challenge lies in balancing simplicity with accuracy. We need methods that are straightforward enough for widespread adoption, yet robust enough to reflect the true complexity of field conditions, the varying site conditions, and regulatory requirements. Additionally, achieving consensus among competitors and suppliers and operators with different historical preferences can be difficult, and keeping these standards updated as materials evolve takes a dedicated effort. In terms of opportunities, by creating standardized benchmarks, we can significantly improve collaboration, accelerate product qualification timelines, and strengthen the overall confidence in the industry. Standard methods level the playing field, so smaller or innovative suppliers with new products can compete fairly against legacy suppliers or products.
Thanks, Stephanie. Jordan and Kurt, any commentary?
Sure. I think there's going to be a lot of challenges throughout this, and I mean throughout phase two of the JIP, when we were trying to agglomerate all the results of say the surveys and phase one, and look at operating conditions and boundaries for all 23 applications that we were looking at, kind of describing and representing. There's a lot of discussion that was back and forth about, what do we think is the right operating bounds or conditions, or how we are actually going to look to accurately describe these types of applications. And that was just a blanket, essentially, not actually defining a well, robust, repeatable, and reproducible test method. So I think one of the challenges is going to be, getting everybody on the same page, making sure that everybody is respected in their opinions and are valid and being included in what is going to be generated as a standard. But I also think that's not only a challenge, but it's also an opportunity for something really good. So I think if we can kind of navigate some of those challenges, there's going to be some really awesome opportunities to develop robust standards.
Thanks, Jordan. Nahil?
Okay, my problem with standards is STM or even AMPPONS is that they are not simple and direct. There's huge amount of useless things they put it in there. The reason that happened is this. I'm currently writing a standard myself. So this goes to the voting and it has to be accepted by everybody. Everybody has their own way of doing things and they don't change their mind. So you have to basically accommodate everybody's ideas. And when you do that, it's actually become bigger and a very confusing test. Well, that is the problem. I think people don't use standard that much because of that. I'm not sure, but that's what I think. So standard needs to be kind of simple and direct, and I can give it to a guy in my lab and say, okay, follow this method, and he should be able to do that. Right now, if I get ASTM G170 or something like that, if you look at it, or G150, you will see that there's huge amount of unnecessary things in there that is not really affected to me. But we could have done a simpler job, but it didn't happen because of the way we are doing in ASTM or AMPP, where they insist that we have to take care of everybody's opinion. So if you wanted to finish your standard, you want to finish it and move away, and then it will take years to finish because you have to support everybody's claims. And then the final product is not very good. That's my opinion.
Yeah, definitely. You've highlighted some significant challenges around setting up a standard for general industry use. I can I can definitely align with those comments and see the challenges that do exist and that you highlighted. Alan?
Yeah, I think the challenge is going to be it's probably not so much from the chemical vendors to adopt the standards because they tend to adopt the standards which are being imposed upon them. For example, there was an API standard for deep water oil field chemicals, and pretty much every chemical vendor adopted that standard. So I think the challenge will be honestly with the oil and gas companies because I wrote a paper down 2 years ago on corrosion inhibitor testing. And I went through a lot of the RFIs we'd received and just concentrate on the high pressure, the high temperature, or the high velocity testing. And I had 8 companies, and each one of those 8 companies had a different test for high pressure or high velocity test from jet impingement, flow loop, HPLCE, rotating cage, autoclave, and so on and so forth. And they've invested in these techniques. They have a lot of data that shows inhibitor performance under those techniques. Exxon, for example, has designed their own autoclave method. So to get these oil companies to adopt these standards, I think that's where the challenge lies, especially under these more extreme conditions, because they have this massive database of inhibitors performance under their own specific tests. So they can look at their database and match the conditions to a new field and then just narrow down the products which they want to test. So I think the chemical vendors are quick to adopt new methods, new technology, that we've all got, or they've all got the test the operators use. So the operators will be the challenge. And if another challenge could be if these standards require the service companies to purchase yet another piece of equipment, but they need more than one, they need quite a few. That could be quite a challenge, for them to convince them to invest in new technology to run yet another test to qualify inhibitors because we have too many tests. And you compare corrosion business to scale. Scale business, they have 2 tests. Corrosion business, we have like maybe 10 different tests. So I think that's going to be the problem. Convincing the operators and convincing the vendors to spend yet more money on corrosion tests. Thanks, Perry.
Yeah, thanks, Alan. Les, interested to hear your comments on this.
Yeah, I think Alan hit it on the nail there, is that I really think this needs to come from the midstream company to the vendor as far as how the test needs to be set up. They should know how their system is operating. They should know the parameters better than any vendor does of their system, and that's how the test should be set up. Then the challenge comes as far as if that requires the vendors to purchase additional equipment, who's going to pay for it? So yeah, I agree with Alan's comments there. I think he hit it on the nose there.
Thanks, Les. We'll move on to question number 4. From your experience, who's led the charge? Technological advancements, operators themselves, regulators, service providers? Is it a financial need, or some other mechanism that drives the change? Les, we'll start with you.
Yeah, in my experience, I think most of the technological advancements have come about based on some kind of problems that arise in the field that are either not being solved with the current treatment or maybe even causing secondary problems downstream. When you have a true partnership between the midstream company and the vendor, then both of them work together to solve the problem. However, quite often it's almost even easier for the midstream company just to look to other vendors and say, hey, have you ever experienced this? If you have, what is your solution for doing this? To see if there already is a solution for the problem or if it actually needs research and testing to develop a new solution for the problem.
Thanks, Les. Alan, any comments?
Yeah, so question is from experience, who's led changes? So if we concentrate on corrosion but testing, I think changes has come from a variety of institutions or organizations. So, for example, universities have driven a lot of the change in new methods development. If you think of Ohio University, for example, with their innovation on top of line corrosion testing and velocity testing using a thin channel flow cell, which they developed and has now been used by some operators, Petronas, for example, looking at that. But then the third-party testing companies such as, Intertek, they've developed new technology, their HPRCE, which is just a high velocity, high pressure preferential weld corrosion test. So they've driven the development of that, which that test has now been adopted by BP virtually as their standard test for qualifying inhibitors. So you got the universities, the third parties, and of course, the oil and gas operators have driven a lot of change. Those ones that had the labs, the likes of ExxonMobil, Shell, ConocoPhillips, all did a lot of work to innovate and develop their own high pressure, high temperature tests. And of course, the service companies have done a lot of work in developing other tests for specific forms of corrosion. I think of under deposit corrosion, for example. So I think the innovation has come from various sectors, the academia, the third-party test house, the chemical providers, and also the oil and gas companies themselves, with regards to corrosion testing, anyway. Thanks, Perry.
Yeah, thanks, Alan. Nahil?
Yes, I really agree with Alan on this one. But then I think when you compare to other industries like pharmaceuticals or catalyst, we are kind of behind in developing new technologies. Remember, even in the universities, we have only corrosion, for example. There are only 2 or 3 universities in the US who have a graduate program. Whereas chemistry or engineering, you have in every university. So we are kind of behind in our new technologies and going into something like robotics or automation. This is very common in other fields like pharmaceuticals, but we are behind. And then this is the future. If you wanted to do anything, the automation is going to be the future because all the corrosion development, all testing will be automated no matter whether you like it or not. But basically, when you compare to other industries, we are catching up. So I would say people in this meeting, if you can start thinking about those lines, and then that will help us a lot. Reducing time and making better products, better test methods, and making the most important is making new products sustainable, and which is a very, very big area. Thank you.
Thanks for that. Jordan, any commentary?
Nothing other than what's already been mentioned, I think. I think there's some really good comment there, especially from Alan around, this being led by universities, service providers, producers at kind of various points in time, and also depending on the method too, right? I think when it comes to kind of standardized methods that we sometimes see for RFPs, for example, at least in Canada, I feel like a lot of the legacy standard conditions that we see some server or operators still kind of provide us are, developed by Shell back in the days, especially in Canada, that were very prolific in kind of drilling into more sour and more severe service zones. And so there's a lot of that we still kind of see from a standardized condition that kind of comes across our plate sometimes for RFPs. But I think everything else has been covered by the group there.
Perfect. Thanks, Jordan. Stephanie, interested to hear any comments you have.
Yeah, I agree with everything that's been said by the group so far. The only thing that I'm going to add is that consortiums such as this JIP have become increasingly the actual vehicles leading these changes as they pool the financial risk and intellectual capital.
Thanks, Stephanie. With that, we'll move on to the last and final question. How do you envisage implementing the standard test methods in your company once developed? Stephanie, I will ask for your initial take on that.
Sure. So we plan to align with these new methods by first assessing them against our existing internal guidelines. And from there, we'll integrate the standard test methods directly into our core workflows, particularly in our product screening, qualification processes, and customer benchmarking.
Thanks, Stephanie. Jordan.
I'm going to let Kirk answer this one.
Oh, fair enough. Kirk.
Oh, now we're fighting over who he's making sure I pay attention and don't just start doing work. No, ours will be very similar. We challenge our standard procedures within our analytical lab, within a lot of the stuff that we do for all of our lab methodologies. So we'll be doing the same and then challenging that to see how those results really fit our real world. I think the one thing, even going back to what we do, um, when we're just looking at our methodologies and how we've developed our methodologies, they also go back to what's actually working in the field. And so a lot of our methodologies have developed over the course of fixing customer problems and not just developing products for RFPs. And so we'll be double checking these with what's actually worked in the field and streamlining our procedures based on that, because that's really how we developed all of our procedures. The majority of our procedures have to go back to actually fixing problems and making sure what we say, what we recommend actually goes out and does the job that it's supposed to and doesn't just work in the lab. So
Thanks, Kirk. Well put. Nahil?
Yes, we will directly would not use standards in our labs. Instead, we will actually test them out first and then see whether it is adaptable to our labs. Number one. Number two is it is actually relevant. Sometimes it's not. Most of the time it is actually. But then the other thing we all have is all the labs have is that the equipment, do we have the right equipment to run these standards? If it is so, can we adapt our equipment to do that? So we will change these standards accordingly to our manpower and to our equipment, but we will be using standards.
Thanks, Nahil. Alan?
As I said before, this is going to be a top-down thing. I don't work for a service company anymore, so I can say the truth. I don't think the service companies will adopt these methods out of the goodness of their hearts. They will more likely adopt them if they are specified in RFPs to state that you have to use method A, B, C, D. I think that's how it's got to come. So you need buy-in from the end users, the operators, and then when these methods are specified in any tenders, then that's how you will get the service companies to use these standards, because that's what happened with the API 17 TR17 or TR6 for deep water chemicals. It was specific. A lot of chemical vendors worked on that first and foremost, but then because it was specified in tenders, they all adopted it to qualify products. So I think it's got to be a top-down thing from the operators, and then they start saying you do this, then all the service companies will adopt it. Because that's what's happened with a lot of the corrosion tests. I mentioned Shell, ExxonMobil, and have their own specific tests. And so the vendors had to buy those tests and that equipment to qualify those products. So if you get it into an RFP, then the service companies, I'm sure, will quickly adopt these methods. Thanks, Perry.
Yeah, thanks, Alan. Yeah, I totally agree with you on that. Having, the operators kind of drive this is kind of really, I see as the path at which the adoption will fully take place. But I think you hit the nail on the head right there with that comment. Les.
Yeah, it's if there's no additional cost to doing this type of test, then I see no problem at all. It's just a matter of informing the lab of the procedures to use. But if there are significant costs or significant equipment, then who's going to pay for that? Everybody is looking at their bottom line, and margins are slimmer now than they ever have been. So that's something that's we'd have to look into, and this may be where a third party lab is the way to go, to where only one company has to spend all the money and everybody contributes a little bit to it, rather than each individual vendor having to buy this equipment to do their own testing.
Yeah, absolutely. Thanks, Les. Jeff, anything additional to add there?
No, pretty much the same thing that Les said. I mean, as you said, and Alan, I mean, basically, if this is universally accepted, the chemical companies will adopt the method and will use it. I mean, the whole idea here is cost and efficiency. That if we can reduce the number of tests, if we're doing some universal test, then that's more efficient for us, rather than doing our own test and then going to an RFP and having to do a second different test. So, I mean, if it's efficient and it's helping our bottom line, we have good ROI, then definitely it'll be adopted and implemented. I mean, the test itself is kind of going to determine where that goes, though. I mean, if it's common equipment, slight modifications that kind of tighten things up, then I think it'll be much more easily adopted. If the standard method, for instance, is a 60-day flow loop test, that makes it very, very difficult for a lot of companies to implement, just due to time and the expenditure to acquire that equipment. So a lot of this is going to depend on what that method looks like, and then kind of going forward on how we implement it.
Thanks, Jeff. Since we've finished up slightly early and we still have a few moments before we conclude our discussion, what I'll do is I'll open the floor to anybody with additional commentary to anything we've discussed here today. I would just ask that you use the raise your hand action to indicate that you would like to say something, and then we'll kind of indicate a pecking order which to present. Any questions from anybody present in the discussion here today?
Terry, there are a couple of questions on the chat from Sadine. But before we kind of discuss that, would you like to go through the couple of slides you had on the focus of phase 3? So that will help to focus our discussion. You remember that you had a couple of slides here. Thank you.
Yeah. Sorry, here. Share my screen again. So kind of coming back and tying back our discussion here today.
Perry, we can't see a slide yet.
Oh, can't see. Sorry. The Zoom share is a little different than Team share. Yeah, so this slide kind of summarizes phase 3 of the GIP best. Basically, phase 3 is looking at what tests are most applicable to the industry and what needs to be the focus. So the first point here, we're looking into the screening testing that would be necessary and most beneficial for the operators. One that would essentially put everybody on the same playing field, from the chemical supplier's perspective, but also from the operator side. So, ones that provide the most economic means and help develop a short list of chemicals that are applicable for their application. Selection testing was not within the scope of phase 3, but kind of more or less a discussion here today. And this slide here kind of shows the overall focus of the JIP to date, and with a particular focus on phase 3, that being the laboratory testing, laboratory test screening, field monitoring inspection, and correlation of laboratory and field corrosion rates. So this kind of ties back into the questions that were laid out here today, and this discussion kind of focused in on the chemical vendors perspective of things. Sinclair, do we want to move into Steen's questions that he's raised in the comments?
Thanks, Perry, but that is for panelists to answer Sadin's question. So if you want to run it through panelist other than me,
Oh,
thank you.
well, that's fair. So Sadine's first question was a standard test method is supposed to be not supposed to be a holy grail document to be followed blindly. The standard method should be a guide that lists the important parameters to be defined for the method. It is a starting point to write a procedure specific to the customer's demands. I think a lot of the commentary here today kind of highlighted that. But I'll open the floor to anybody with additional commentary to that. I think from points like Alan and Jordan and Stephanie brought up, even Nahil, it's very operator driven. It's going to be whatever the best fit for the operator is going to kind of drive the best appropriate test method. But I'll open the floor to anybody with some additional commentary.
Can I put a comment?
Oh, go
This
ahead,
is Sadine. Yeah.
Yep.
Sorry to bug in like this.
No worries.
This is Sadine from SET Laboratories. We have been in business for 28 years doing inhibitor qualification. The biggest thing I see is between the operator and the vendor, sometimes there is no correlation. The vendors ask for tests that's the 1 week, and after the operator take all those results from different vendors, and they come back to the lab and they do a month test or 3 weeks test. So sometimes that's why I'm putting things that the duration that doesn't there is no standard that says which duration, what's the minimum at least duration, because with the shorter term the results are spread. That's a big spread in the results, the shorter the duration. The longer duration, you start having something that's more accurate, more precision. The other
I
thing is, I get some people asking me to put 50% oil in autoclave, and I tell them 50%, basically you're going to get zero corrosion rate. There is no need to do the test. But they still the operator asks them to test like that or something. So the standard should give the list of important things, and why the things are possible or not.
But I think if the standard isn't really specific, it'll be so open to interpretation. You will get the variability in the test that you just described. People doing different durations. I think you said it shouldn't be a starting point. I think it should be the end point. This is how you do the test, and it should be quite explicit with regards to brine preparation, your pre-corrosion, duration, all these things. If you don't be explicit, it's open to interpretation, and then we'll have the same problems as we have now. Everybody doing different things.
I think I like Sadine's question because for several reasons. The other day I got a request to run an RCA for 1 day. This is autoclave test for 1 day. Then I said this is no use. However, the customer insisted. So we did RCA for 1 day and we did RCA for 7 days, and then look at the data and with them. This is running 1 day is totally useless. So it is important from standards that you have something to prove what you're talking about, and I think running certain time frame, for example, sour corrosion, and you are looking at pitting basically, and pits don't form within say 2-3 days. You have to run at least 2 weeks to see pitting. General corrosion is not that important in that. So pitting is the important criteria. So basically what I'm trying to say is I'm agreeing with Sidine that you have to convince customer or whoever asking you, this is not really the way to go. So standard is therefore something that we can actually hold into and prove that it is no point of doing that. You are wasting your time and you are wasting our time too.
Yeah, period. I think my comments, I kind of agree with the panelists in a couple of ways. I mean, in terms of Alan, I completely agree. This is going to be a standard method, then it has to be specific. Otherwise, we're exactly where we are now, right? Whether we like the standard, whether it perfectly represents the field or gives us the right answer, that's going to be the big challenge. But if you're not specific, then it's a guide, and everybody's going to do it slightly different based on what they think are the important parameters, and we can't compare or have reliable data. So, I mean, I think it does have to be very specific. I mean, to that end, to make a recommendation, you might need multiple methods, right? To make a recommendation for midstream, we might have to do a flow loop or jet impingement or RCE, RCA, autoclave. You might have to do multiple things because just an RCE test probably isn't going to be enough, enough insurance or enough confidence in that result that you're making the right recommendation for the field application.
The way I look at the standard is that should list all the information that should be before writing procedure for that specific test. Sometimes I get somebody wants to do a rotating cage. He doesn't tell me what's the shear stress. He doesn't know what the shear stress is in the field. He doesn't give me. He knows the temperature and the brine. You cannot really do anything. So you start asking questions, and that's where the standard should have basically the basic. What's the all the parameters needed.
Yeah, but we have that already though. We have what's needed now. We know that. We have questionnaires we can send out. But then when we get all this data back, we just interpret it our own different ways and do our own things. Simple things like how to pressurize an autoclave out of sparkling gas, how to make up a brine. Do you leave out scaling irons or not? So there's like simple things that are open to interpretation. So we get all this information, we know what we need. We get that from the customer eventually, and then we decide how to do the test and what tests to do. So if the standard is vague like that, like you're suggesting, we aren't gonna make any progress.
No, but what I'm saying, the standard should list the those things.
Yeah,
The purging time, 30 minutes, an hour.
yeah,
There is some
exactly.
companies
Yeah,
who like overnight. There
yeah.
is some companies they say 4 hours.
So it's got
So
to be
if you don't say
yeah,
anything, I will do an hour and that's it. Because I know that an hour is enough to have zero oxygen.
not if you've got a gallon of brine. It's not.
Yeah, I know,
Mhm.
but do you see
You
those that
see?
should
Yeah,
in the
that's what.
standard just saying
Yeah,
how just saying that you to list that shear
yeah.
stress to say what the shear stress like the corrosion inhibitor is it total fluid or just the brine? A lot of people don't they just give you ppm without saying it that's total fluid or the brine or
Mm. Yeah.
so those things small details that's where you can have two labs basically getting different results.
One other comment to throw out, Perry, as far as
Oh,
in the slide that you have step one and then step two.
mm,
Why why would you even do a screening test if it's under standard conditions? Why not get all the exact field conditions and run one test? That's one of the big. I'm always thinking of cost to prepare RFPs and bids, and having to run only one set of tests to get exact results rather than running a screening test and then be selected to run a final test. Especially if the screening parameters may be in a completely different set of parameters that the corrosion inhibitor that you picked doesn't work or may work under those conditions, but may not work under the specific conditions of the field.
I think that's the vendors who need the screening tests. If you have the condition in the field and you have 10 chemicals that you can apply, you have to have a way of checking all the chemicals really fast, which one is the
yeah.
best. And that's what concentration. That's why you need the screening test.
Yeah, I think the screening test more or less provides us as the operator a context to work from to at least establish a baseline of who should participate in the final verification testing. At least from my perspective. Um, then usually after that, we proceed to a laboratory evaluation. Um, Preferably from my side, it's usually like a third party blind test comparison between the various vendors.
Yeah, Les's comment is definitely I think super important to think of, and that's something that we discussed a lot when it came to looking at or condition envelopes during kind of this screening test ideology or ideation that we were doing, because that's exactly that. Like if you're looking at say just sweet conditions, well,
Mhm.
largely there's different products that we would look to apply based off, if something is considered sweet or something is considered sour. There's classes of inhibitors that perform very differently under those conditions. And so that's where, from a vendor perspective, we spend a lot of our time just participating in that more pinpointed selection test because it's lower operating costs. We're not repeating work. But you guys are right too. We need to find somewhere that at least has some sort of middle ground that has capabilities across numerous laboratories where we can all play on the same playing field that can then kind of get us to that selection test. But I think from a chemistry perspective, there has to be some nuance because things can be designed to perform well in tests depending on conditions and not necessarily perform the same under more pinpointed selection test conditions.
We've got about 1 minute left. Any additional commentary from anyone here, part of the discussion? I'll, we can leave it for one more comment.
I think it's been really very enriching to listen to you guys, talk about really interesting stuff the last 1 hour. So thank you very much for the rich conversations.
Thanks, Arya. Yeah, to that point, actually, yeah, this has been a great discussion. We probably could go all day versus just an hour. So I definitely appreciate everybody's time, and thank you all for participating in today's discussion. I really appreciate it, and yeah, thanks again.